Yeah, starting recorded. Started. So, hello. So today we are going to discuss about the inter VLAN routing. So inter VLAN, as name suggests, as name suggests, inter VLAN routing means whenever you have two computer, okay, two system, okay. So in that, and this having the this network, I mean dot one, and this system having 2.2.2.2. So as soon as we are configuring the IP address to system, please listen carefully because you need to explain multiple times this. As soon as you will assign the IP address to system, it will run a AND process. Okay, AND process is nothing but it's going to check how many IP address, I mean range, usable IP address range. Okay, how many usable IP addresses will be on the same subnet by the help of subnet mask. You understood the use of the subnet mask? By using subnet mask and the network, system will do AND process and it will find that destination IP address, for example, 2.2.2, it's on same network or a different network. If it is same network, then system required destination system MAC address in order to communicate. If it is a different network, as in our case 2.2.2.2, then always system required gateway MAC address in order to communicate with the different network. You got it? So computer will send the packet to direct to that PC if we have a same network. If you have a two different network, then packet always go to gateway and then it will go, and now gateway responsibility is to make the routing between this network and this network. So once, in straightforward you can say, once we have a two different network, and when we are going to communicate with two different network, we are calling as a inter VLAN routing. Clear? Do you have any question? As soon as you will assign the IP address, it will do AND process. By AND process, it will see how, what is the usable range, what is the range with IP address range on this given subnet. Okay, once subnet found, then it will check destination IP, for example 2.2.2.2. If it is same network, then it will send to generate the ARP and send to that particular device, I mean destination device. If it is a different network, in that case it will send the traffic to gateway. I hope clear, right? Let me know if any question. It will be more clear once we will do the lab. Clear? Please mute yourself, man, once you are saying something. Okay, interval when system are going to communicate to different subnet. I can say subnet, right? There is no issue. Subnet network, whatever you want, you can say. When system are going to communicate with two different subnets, then we will use inter VLAN routing. Clear? Okay. So inter VLAN routing there are three methods. First, inter-VLAN routing. Second, router on stick. Third is SVI, switch virtual interface. Okay, clear? We have three methods. First, inter-VLAN routing. Second, normal router on stick. Third is SVI. So all the things, every method is going to do the same. Only thing is that little bit configuration will be changed, terminology will be changed, or something like that. So inter-VLAN routing. So I will explain here. After that, we will go and prove that. Okay. So first, inter-VLAN. For example, if you have a route, you have a switch, you have a two VLAN. VLAN 10, IP address 1.1.1.1.0/24, and here we have a 2.2.2.0/24 network. It's not only one PC, we have multiple PC connected here. Okay, like that in the each VLAN. Okay, and then we have a cable which is going to routing. Okay, so two VLAN you will create here. First of all, you will assign the system IP address to computers. After that, you will configure two VLAN on the switch. Okay, and then you have also need to connect two cables. Means in this port you will assign VLAN 20, and this port you will assign VLAN 10, and here you will do VLAN, I mean IP address, gateway IP address of the VLAN 10, and here you will get IP address VLAN 20. After that, communication will start happening. I will show you normal communication before giving the IP address to router. After that, I will show you like someone is you guys can also admit the people, right? Okay.
I think maybe.
Okay.
So
No
because
worry. No worry.
yeah, I can.
Okay. Please. If someone is joining, you can go ahead and do that. This is but drawback is, what is the drawback you can see here? If you have a 10 VLAN, then you have to 10 physical interface need to be connect, right, with the switch and router, right? You have a 100 VLAN, then
Then
we
you
have
will
a
have to
problem,
spend
right?
100. Yes, 100 interfaces.
Yeah, but router is kind of a device which we cannot use multiple interfaces. Generally, you will see 4, 8, 16 port devices. Depend on the use. Depend earlier is beginning router, you will see only 2 port, but you will get some module over there. You can purchase the module or increase the port. Okay, so this is the also option was there earlier, but nowadays router having bigger port as well. If you will use some big devices, for example data center devices or something, you will get n number of ports. But generally router, it's coming with less port as compared to switch, but it's already lot of problem will happen. For example, one interface went down, that user, that particular VLAN user cannot communicate to other. And the management, if you have a lot of interface, management of the network will be high. And also you can see, I ask for example, one port is not working, might be cable faulty, SIP module got faulty or something went wrong here. In that case, I ask local IT. We will send to someone to site locally, and we will ask like as Parvez is doing the work sometime. There is his. I asked to replace this cable. By mistakenly, he replaced this cable. He disconnected this cable. So this VLAN was down. This also went down by disconnecting single cable, right? So this kind of a problem you will see in the inter VLAN routing. It's a very big mesh connectivity, and then management is very tough and cost effective as well. You can see multiple interface you need to purchase, multiple SFP module you need to purchase. You need to purchase good quality of router where you can find multiple interfaces. So a lot of problem will happen in inter VLAN routing, right? So we have a like updated model which we are saying as a okay. Before proceeding further, I just wanted to ask, do you have any question?
No.
Okay, great. Let's prove this first. After that, we will go ahead and do that. Uh, we can use packet tracer. This is lab is small, so we can use the packet tracer over there. So stop sharing a minute. Give one moment. Just I'm logging with here. Okay. Let me know once you will see my screen again. Able to see my screen?
Yes.
I can take one device will be fine. One router, one device, multiple VLAN. Okay. Computer maybe you can take multiple two computer that will be fine. Two VLAN or you want to make multiple VLAN?
Two VLAN is enough for.
Yeah, two VLAN because here I need to again add the port. How you can add the port here? See, if need multiple port for example, right? So we have some serial port here. You can see. So you can just go ahead and put somewhere here. First, you need to power up the
Switch
device,
off.
and then go ahead, yeah, and turn off the device. So you will get multiple port, but generally see one to one console port. See how devices is it? Uh, you know, it's same exactly. You will find the devices in the network as well. You will get some button, and this is also you can see it's a working devices. Nowadays is someone is using that. Okay, so this one is a console port. Okay, this is auxiliary port. We are saying our aux port. I'm not sure, but this is the one port two port. So first is gig 1/1, for example. Here gig 1/0/0/0/1, for example. Here we have a small console connection. Sometimes this is also console. Sometimes saying both console you will get this mini console. We are saying this is mini console. This is you know uh, traditional console. These are the two ports. Oh, these are the two ports. See, gig 0 and here you will get total four ports here. This is auxiliary port. Auxiliary we are not using nowadays. Auxiliary devices means might be you heard about UPS, PDU, NetBoost devices. Those is coming auxiliary devices, and also we are using for to access the devices. Sometime aux port we are calling. We can access it, but I have not seen, never seen that we are using to access the devices. We have a console port. This is console. This is console. Two console we have. I mean this one or might be this one. Name is not written here, so here you can see SF, you know, USB port here. So these are the kind of scenario, kind of devices you will get like that. See, only 4 port you are getting, but switches you have n number of ports, right? Like that. No, how you will check in the router? You can note down how you will check how many ports you have in the router. So interface brief. So IP interface brief. You can see how many port we have. This one, 2 serial port we have added. I have shown you like how we are purchasing the module and adding there. So you can purchase the module from the Cisco or whatever vendor devices you are using, and then you can turn off the devices and just ask local IT to connect this one and turn on the simple. Okay. I will explain you how real scenario we have. I have couple of. I will explain. See, this port, 3 port we have, and 2 console port. VLAN one is by default one, management one. Anyway, I will configure router later on. Let's connect the devices. Okay, these are the 2 port. So go ahead and connect this one first. Okay, go on computer first and assign the IP address as you are doing. For example, 10.10. Just take the same example, 1.1.1.1. 10. Just take 10. Here I have given 24 IP, 254, 255.0. Okay, done. Gateway IP address. Okay, I will show you what else, what happen if you will not give the gateway. Okay, then after that we will do the other things. Okay, I have seen this multiple time interviewer ask the question. If you do not define the gateway on the system, what will happen? Or incorrect gateway, what will happen? 1.1.1.
Uh, what was the question?
Question was, if you will not define the gateway, what will happen? 11 I have given. I am not defining the gateway. Here we are going to assign. I already explained someone, but I don't know how guys are remain doing the things. I think I already explained. 2.10, and here I will assign 2.11. So pay attention, here we are doing some basic configuration and very important things for beginner 11. So do not miss the class from now onwards, or else you will face the consequences. Okay, I have assigned the computer systems. Okay, IP addresses. Now we will configure. See, red, right? By default, router port is not coming up. Okay, so now what I need to do, as I explained first, we are going to assign the system IP address to the computers, and then second we need to configure the 2 VLAN and assign the VLAN to particular systems. Okay, so config host name, okay, config t, host name is number one, and VLAN 2, for example. Name you can give Abhi. Okay. Then we have VLAN 3. You can give name as Anu. Okay, and exit. So both VLAN configured. Now assign the computer, assign the system 3 and 6. 3 and 6 will be in VLAN 2, right? Interface FH0/3 switch port mode access. This command, you know what is doing, right? Mode, what is mode my VLAN is going to disable the DTP and all, you know that.
Yes,
Switch
access.
port, access VLAN 2. Now assign to 6 number as well. 6. Switch port mode access. Done. Now configure VLAN 3. Set VLAN 3. VLAN 3. Here you can
4 and 5.
port number 4 and 5. So assign 4 and 5 to VLAN 3. Interface FH0/4. Switch port
By
mode
giving range, we can
access.
also send.
Switch port. Oh yeah, we can do that. 4 5, right? So you can use the range. Go exit. How you are going to, if you have serial wise multiple interfaces, you can use the range command. If you have random one, then it's I don't know how you will feel. Maybe it's the first time you will heard, known as smart port micro, a technology in switching we are calling as a smart port micro. So we are grouping the interfaces which is random. For example, 4 is here, 6 and then 8, then 10. On those random ported we need to configure the same kind of VLAN or other configuration. In that case you can also use the smart port micro, and then you can give some name and then assign the things. I have never seen like interviewer asking this type of question, but that's what I skip that topic. Anyway, so here you can say interface range fh0/4 -5. Like that, always you need to give the command. Then you need to give switch port mode access, switch port access VLAN 53. Done. Now we have done. Now your PC, this PC can communicate to this PC. For example, just take ping 1.1.1.11, right? It's pingable, right? But my question was, what will happen if you want to ping to other computer and you have not defined the gateway? This one I have frequently interviewer asking the question sometime when it's for not L1 and L.5 or level interview they will not ask. As per my experience. But if you are going L2 and L3 and data center tech uh, like that roles, then they definitely are the packet level things kind sometime. Anyway, so just I'm owning the simulation, and I will say ICMP or ICMP will be okay. Leave that on other packet. Okay, I will enable the simulation. Okay, now what will happen? You can see communication. I have shown you within the VLAN communication is happening before going to gateway. But as soon as you will configure, you will give 2.2.2.10, for example, this PC IP and giving this PC IP. Then what will happen? See, system generate the ARP and a ICMP packet. See, ICMP packet is type 8 is generated for this network. See what is a ping is process started next ping request. Okay, then this the ping process created ICMP echo request as I already explained, and this one not on same. See here, this destination IP address 2.2.2.10 is not on the same subnet and not in broadcast address. The default gateway is not set. This device drop the packet. See, he's saying what? Device itself
Yes.
drop the packet. See here is dropped. I have asked multiple time interviewer asked. First time I was not knowing that, so I investigated and learned. So if you have not defined the gateway and you are trying to reach out to different network, then packet will be dropped immediately on the PC itself. Okay, because as simple as that, frame will not be completed because we are not receiving the destination gateway MAC address, because as per the process what we are calling as if we do not have a gateway MAC address or destination MAC address, we cannot process further. If destination MAC address is not available within the network, we will write the ARP request. So ARP request where you will rise, because we are asking gateway to provide the MAC address, but gateway is not set. It do not have a destination IP address itself, right? Because once we have like this one, we are giving destination. This is destination, right? If gateway is not defined, means destination is not defined. If destination is not defined, then how packet will know, how computer will know where we need to go? Then itself it will drop the packet. You got it? Why it was dropping?
Yes, clear.
Right? Because destination itself, because our destination for the different network is a gateway, and gateway we have not defined. Simple, right?
Yes.
Okay, great. Let's do that. Let's define the gateway now. And what will happen if I will define the gateway for this PC? Wrong gateway. For example, wrong gateway. What will happen? Then packet will be dropped or not? I define the gateway here. What will happen? Tell me.
No, packet will be dropped.
No, it will not drop because you have defined the gateway, right, already. So whatever wrong or right, the system will not check. It is wrong or right. It will gateway should be on the same network. That it will definitely check. Gateway should be on same network. That keep in note in somewhere, because once you will learn the routing, and if you know very well routing, how packet will exit, how packet will flow between the routers, then you have to understand the gateway concept. Anyway, that we will explain how you are
You
reading
were
the
saying
routing
that
table and all.
the gateway should be in the same subnet, right?
Definitely it will be
Now,
always.
my question is, like PC1 and PC4, both are in different subnets. Then,
Mhm.
do we need to define two gateways
Mhm.
at the switch level? And that's my question.
Definitely, we need to define two gateway, but not switch level. It's a
Okay,
router level. I will let you know switch
okay,
level where we are going to define. I will explain that thing
okay.
as well. Okay, don't worry. So we have defined the gateway on the same subnet, but what will happen? You can just check first ARP also. Let me ARP also will go right. So let me enable the ARP as well. So ping 2.2.2.10, for example. See, now packet will be go to gateway. So whatever gateway is system or computer, this is this computer system. This is a router system, right? So packet will reach here and it will drop the packet because it's this device. Don't consider this is a system as of now, but consider the router. If router do not have a routing to reach the 2.2.10, then it will drop the packet. Simple. How? See how it will happen. It's define the gateway, but wrong gateway. This is ARP, address resolution protocol. First R will go, R will reply. This system will reply ki I am gateway, because none of the packet is saying I am gateway. I am asking to provide the MAC address of your whatever gateway defined in my PC. As simple as that. See, it's returning as well. See, as a layer 2 communication is done. Now R will ICMP will be generated. See, ICMP will reach here, and then this system will drop the packet. See, it's dropped, right? How? You know that. I already explained. Because this system do not have a route or facility, whatever you can say, to reach 2.2.2.10, right? That's what is dropping the packet.
Yes.
Okay. Now let's go. We have defined the gateway, and now, as I explained here, you can see we need to define this VLAN as well, right? This interface also we need defined a VLAN, right? Each interface will define one VLAN. So define the VLAN here as well. So this interface FH0/1, FH0/2. So any port you can define anything. So if you want to define FH0/2 VLAN 3 or VLAN 2, that will work. Here you can define anywhere, but should be defined. So go ahead and device switch and configure the okay VLAN. So exit
Uh,
interface
so
FH0/1.
the communication between two different PC is still not established, right? It's not still
No, not
working.
without gateway, without router we cannot do that. Switch port access VLAN 3, VLAN 2. This one I assign the VLAN 2. This one This one I will assign VLAN 3 to switch port mode access, switch port access VLAN 3. Okay, done to write MEM. Now switch level work is completed. Now go on router. This is the router. Enable config t host name R1 do write MEM. Saving the configuration. Just give a moment. GI 0/0/0 GI 0/0/1. Now you have to remember now. If you defined FH 0/2 as a VLAN 2, then you have to define here VLAN 2 IP address. You will define 3, then will drop. Because how? It's local how you are doing, right? Snipping. Let me explain more. Might be you forget the basic thing. Okay. This is the device. For example, this is the VLAN 3, right? It will send the traffic here. Switch will see where this VLAN 3 is assigned. For example, here is assigned, here is assigned, here is assigned. It will forward this packet here, layer 2 communication here. But once it packet reach here, you have doing the tagging here. Tag. Tagging will perform by router somewhere. You will define here. Then tag will be mismatched. Then router will drop the packet. So you need to, if you are configuring VLAN 3 here, then VLAN 3 gateway should be defined. VLAN 3 gateway should be defined.
Okay, so each particular VLAN we have to define a gateway, right?
Yeah, in this method, but we are not using nowadays.
Okay.
But I'm explaining what was the beginning.
Okay, so this is
So
what this
see,
this was old method.
all the port is showing red. Yeah, this is old one. All the port is red because in router we have some specific command which you need to run to make the port up. Okay, then configure GI. How you will check which device is connected? So first GI 0/0/0 first interface GI 0/0 no shutdown. Then no shutdown important. See, it's become a green, right? So no shutdown is a command which is going to initiate the interface of the router. Until only will not give no shut, it will not initiate. No shutdown. Done. Now you have a command. I have not teach you CDP neighbor. I will teach you services once I will learn. So you can check this device. From this device where you are logged in, we have two device connected. Two device connected, right? A CDP protocol, Cisco Discovery Protocol. This is a
Okay, so
layer 2
so
protocol.
it means it's saying that on two interfaces we have two devices connected, right? On 0 and 1, and
No,
it's
same device
it's switch
connected,
one.
but two
Yes,
different port.
same,
There are
but
two
two
interfaces.
different ports. Yeah, that's what I
Yeah.
mean. That's what I mean.
Here also you can see what port is connected. I mean remote port. This port ID we are saying as a remote port. Sometime you will say remote, some vendor, different vendor. Sometime you will say like that. And platform also you can see 2960 switches we are using, right? Hold down timer is 180 second is there for the CDP. 60-second hello timer. Anyway, so these are the devices. How you will check how many devices connected with the network? So go ahead and configure the. I will explain about the CDP and LLDP, link level discovery protocol, and Cisco discovery protocol. Both one is open standard, one is
Open
uh,
Cisco
Cisco
protocol.
properties. So I will explain both how it's working because it's very important. And every network engineer running tens, hundreds of time in daily in their daily work those commands. Anyway, now go ahead and GI 0/0 login on the router, then config T GI 0/0/0. Sorry, I'm missing interface always. Okay, IP address VLAN 10 1.1.1.1 1.1 gateway 0. No shutdown. I have already given, so no need to worry. 0/1 IP address 2.2.2.1. No shutdown. in company also you will see first IP or last IP we are putting as a gateway IP address, so you can use anything. Okay, first IP and last IP. I 90% case you will see first IP, and 10% might be case you will see as the last IP in the company they're using as a gateway. Now let me explain you how packet flow will happen. Wait. Packet flow will go in deep dive, don't worry, but just explaining here how packet is going nowadays. This will generate the echo packet, right? Echo, then it will hand over to, because this echo is ICMP is layer 3 protocol, then it will add source IP address, for example 1.1.1.10. Destination IP address, what will be happen? For example 2.2.2.2, right? 2.10. And here protocol number P11 TTL value will set 128, for example. Then it will hand over to layer 2. Layer 2 will add their header. Source MAC address, computer MAC address, 0A for example. Destination MAC address, this one. This is, see, now is our different network. If we have a different network, then always packet will go to destination. Packet will hold here. Okay, then R will generate it. This packet, this do not have this MAC address because it's a different network. If a computer will check is trying to reach on different network, then always it will hold this process and initiate a ARP packet. In ARP, what it will do is this packet will be hold until ARP will resolve. ARP packet, what will be happen? Source MAC address 0A, for example, MAC address, gateway MAC address 0G, gateway MAC address, and this is ARP, then 800 is Ethernet type code 806. It will add and it will send to here. Then it will reach out to here. Then this will reply to gateway to this one, like gateway. Once gateway is received, then always this MAC address will be same. Here you will see always put the 0G gateway MAC address. Okay, and then it will put the 808x0800. This is IP packet, right? Then it will put IP1 because R put and here Ethernet type. Already explained everything, right? How ARP working. It will reach out to gateway. It's reached. Then again this packet initiated. Next packet, first packet will be drop something, and then next packet will generate it. It will reach out to here. Switch will build MAC address table. Switch will build MAC address table. After that, it will reach out to gateway. Now gateway check the routing table. Routing table. Okay. Once it will check the routing table, then it will see which interface 2.2.2.0 is reachable. So it will say here this interface. Then it will packet will send on this interface. This it will receive. Then it will see which VLAN it is, because layer 2 how switching is working. It will receive on the one VLAN. It will forward check is VLAN 3, for example. VLAN 3. It will send to all the VLAN 3 IP first time. Then for example 2.10 IP address this one, then this system will reply, this system will drop the packet and reply how it is working, like that. This is the packet flow will happen in the uh, in the inter-VLAN routing. Okay, now let's
Yeah.
prove this. All good? Is there any confusion, question?
No,
2.10.
no question right now.
So first of all, I will control C. I will go real, because packet will drop all the packet, because we have not set the proper gateway, right? So define the proper gateway. What will be the gateway here? Gateway will be always whatever you have configured on the router. Generally, this gateway will receive by the DNS server. Oh, sorry, DSCP server, and you have no need to give manual IP address or anything. But that whatever you will system will receive gateway IP address, that IP address will be always and always will configure as a gateway IP address. Okay. So 1.1.1.1 will be gateway. Earlier packet was going this PC, but now packet will go some other PC. I mean here, not defined, 1.1.1.1. Defined here, define the gateway, 2.2.2.1. Here, 2.2.2.2.2.1. Okay, then now go ahead and ping and simulation on enter. Now see, two packet is generated. First, ARP, you know, always first it will send to ARP. Then ARP switch will learn the MAC address table as I explained already. Now it will go to first interface, this interface router. Now router, what it will check? It will check the routing table exit. It will check the routing. How routing table you can check? By the using this command. So IP route, this command, make every command. So if router wants to communicate this IP address, then it should send the traffic 001. If router want to communicate this one, then it should send the traffic on this interface. Okay, this how you will read the routing table. This is the interface directly connected. This is locally assigned on the interface. Always you have assigned /23, but it is working as an individual IP address on the interface. That's what you can see as a /32. And this is the
So
same interface here.
if there will be hundreds of machines, then they'll all show here, like the entire list.
Yeah, it's entire list. Is you cannot run this command. You need to filter something because thousands of route, lakhs of route will be
Exactly.
available in the
That is
company.
what I. That is why I wanted to ask, because
Yeah,
I
so
think
you need to
it
filter
will
like
consume a
that.
lot of, yeah,
So
it will consume a lot of data, and it will take a lot of time
yeah,
to
yeah,
fetch
you need to
the data.
give this include. I will explain. Don't worry,
Mm,
everything I will
okay.
explain. Like that, you need
Okay.
to copy and then paste. I don't know. Here is I never tried. Here is
So
working or not.
so
See,
the first
we
point,
need to filter
it's
like that. If
yeah.
1.1
So
you want
the
to go, it will exit like that. So, like that, you
so
need to
first
filter. This is a filter
uh,
command.
uh,
Mhm.
so the first it's asking. I mean, it's mentioning the subnet, right? Like 1.1.00/8,
Yeah, because you
right?
configure on the interface, it will come into routing
Okay.
table
Okay.
directly. Yeah. So routing table, don't worry, you will learn all. So packet is reach here as I explained, then it coming here. See, its packet is coming here. Then it will check the routing, what VLAN it is. It will send to here and here as well. See. Oh, okay. This is ARP actually because it's resolving the ARP, right? See, this is ARP. So fine. ARP is resolved. Now ICMP will go. Now ping packet will go. It will go directly gateway. Here it will not come again. See, it reach out to gateway. Get to drop the packet. How? I don't know why. Okay, might be different packet. That packet was dropped. See, two packet is came. Okay, now see this one is dropped. This one dot 10. Then it will reply to gateway. It will reply always gateway. It will not go direct communication. Will not happen. Always via gateway. All the communication will happen. Now see what happened. Okay, let's see. Something drop. Yeah, communication one packet is successfully came. Might be some other packet was there. It's SMP packet. See, if you will see here, one packet got successfully pinged. Here, see, reply from 10.1. Clear how packet is flowing. Okay,
Yes.
I'll stop recording and I will ask like any question or doubt, and then I will start recording again for the router on stick video and then SBI like that. It will be okay, or we can
Yes. We can stop the recording and then record again.
okay, or else video will go lengthy and high.
Yeah. It will be.
Okay, let me start the recording.